In this video, we're going to go over momentum as it relates to conservation of linear momentum. Now, before we begin, let us do a nice overview on momentum. Momentum, it is something that is accomplished by a moving object. Momentum is equal to mass of the object times the velocity of the object, and momentum is symbolized by lowercase letter p. Now, in a collision, momentum will be always conserved, meaning that sum of momentum before collision will be equal to sum of momentum after collision. This principle is known as the law of conservation of momentum. Make sure you understand this principle because we're gonna use this principle a lot in this video. Let me erase this part because I need to talk about something else. Under this topic, there are two main types of collision: elastic collision and inelastic collision. So for both collisions, momentum will be conserved. Let me erase this part. For both collision, elastic, whether it's elastic or inelastic, momentum will be conserved. Let me symbolize momentum by lowercase letter p. Will be conserved. For both collisions, momentum will be conserved. But the main two difference between these two collisions is that in an elastic collision, both momentum and kinetic energy are conserved. In an elastic collision, only momentum will be conserved. Kinetic energy is not conserved. So there are some situations behind these collisions. In an elastic collision, when objects collide, they usually bounce off. They will bounce off. And in an elastic collision, when two objects collide, they will bounce off, but there will be a maximum loss of kinetic energy. And sometimes when objects they collide, objects they will stick together. They usually stick together when they collide. Let me erase this stuff. So they usually stick together in an elastic collision. Now let us put this information on practice. Let us try to work on some examples problems. Let us dive on practice problems based on conservation of momentum. Number 1. A 2000 kg car traveling at 25 meters per second collides with a 1000 kg car. After the collision, the two cars move off with a velocity of 10 meters per second. Calculate the initial velocity of the 1000 kg car. Now we have two objects colliding. Then sum of momentum before collision will be equal to sum of momentum after collision. Now, since we have two objects, then that means mass of momentum of object number 1 plus momentum of object number 2 before collision will be equal to, since these objects decided to stick together after collision, they will have same velocity. Then that means they will have same velocity. If whenever two objects they stick together, they will go with the same velocity. Then that means we need to take out the common factor of velocity, and then we're gonna add their masses. Mass of object number 1 plus mass of object number 2. Object number 1 weighs 2000 kg times initial velocity of object number 1, 25 meters per second, plus mass number 2 is 1000 times initial velocity of object number 2. Object number 2, we are not given the initial velocity of object number 2. It is the one that we need to look for in this problem. Then the final velocity of the final velocity for both objects is 10 meters per second, and mass one is 2000 plus, so let me fix here, it's 2000 plus 1000. If you punch this on calculator, you're gonna get, let me punch this, it's 10 into 2000 plus 1000. So on your right hand side, you're gonna get 30,000. It's 30,000. Then here it's 2000 times 25. You're gonna get 50,000. You're gonna get 50,000 plus 1000 times initial velocity of object number 2. Let me erase the top part so that we can continue to work out the initial velocity of object number 2. We no longer need this stuff. Now let us transpose 50,000 to the other side of the equation. So we're gonna left with, on your left hand side, you're gonna be left with 1000 times initial velocity of object number 2. So on your right hand side, you're gonna left with 30,000 minus 50,000. 30,000 minus 50,000 it's negative 20,000. Here it's 1000 times initial velocity. If you divide both sides by 1000, you're gonna get negative 20 meters per second. So let me erase these parts. Since we have a negative velocity, then that means it's going to the opposite direction of the motion. So that means since we said then that means the object number 2 was going to the right. Then that means initially object number 1 was going to the left. Number 2, a 0.2 kg clay ball moving at 4 meters per second collides with and sticks to a 0.3 kg clay ball. After the collision, the combined clay mass moves off with a velocity of 2 meters per second. Calculate the initial velocity of the 0.3 clay ball. Now, so this is how we're going to solve this problem. They want the initial velocity of 0.3 kg ball before the collision. So before the collision, we need to add the momentum of these two objects, of these two clay ball, and then we're gonna equate with the momentum with the sum of their momentum after the collision. So it's mass 1 v1 plus mass 2 v2 is equal to mass 1. Now since these two objects after collision they stick together, then that means they're gonna have the same velocity. We need to add their masses. So before collision, 0.2 kg ball was moving, let's say was moving to the right with 4 meters per second. So the mass of object number 1 is 0.2 into the initial velocity of 4. Then the mass 2 is 0.3 times the initial velocity. Their final velocity is 2 meters. Since it's positive, then that means these two objects, they were moving to right with the same velocity of 2 meters per second. Now it's 0.2 plus 0.3, 0.2 plus 0.3. Let me erase the top part. Also the sketch, so that we can solve the initial velocity. What's happened here? How? I'm trying to erase here. Now on the left of our equation, so let me also transpose 0.4 times 4 to the right of the equation so that we can solve for initial velocity. So on left, you're gonna left with 0.3 times initial velocity. So on right, it's 2. So it's 2 into 0.2 plus 0.3. Then you're gonna subtract with 0.2 times 4. We're gonna left with 0.2, positive 0.2, divide both sides by 0.3, divide by 0.3, and then our final answer is 0.67 meters per second. Then that means the object was moving to the right but at the lowest velocity. Number 3, two ice skaters, one with a mass of 60 kg and the other with a mass of 80 kg, are initially at rest on an ice rink. They push off each other and move in opposite directions. If the 60 kg skater moves off with a velocity of 2 meters per second, calculate the final velocity of the 80 kg skater. Then it's mass 1, or let me attach the pen first. It's mass 1 times velocity 1 plus mass 2 velocity number 2 is equal to, since they didn't stick together, these two skaters, they didn't stick together after the collision, then that means it's gonna be mass 1, but now it's a final velocity of final velocity for object number 1, and mass 2 times final velocity of object number 2. Now these two skaters initially they were not moving, then that means their momentum is 0. The 60 kg skater was moving with a velocity of 2 meters per second to the right, plus 80 times the final velocity of 80 kg after the collision, after they pushed each other. Now we need to work out final velocity. Let us transpose 60 times 2 to the other side of the equation. 60 times 2 is 120, is equal to 80. It's negative 120 times final velocity. Let us divide both sides by 80. So the final answer is negative 1,5 meters per second. Since it's negative, then that means the 80 kg scale was moving to the right, to the left, I mean, with a velocity of 1.5 meters per second. Number 4, a 0.1 kg tennis ball traveling at 20 meters per second collides with a 0.2 kg tennis racket initially at rest. After the collision, the ball rebounds with a velocity of 10 meters per second in the opposite direction. Calculate the final velocity of the tennis racket. Now, remember, sum of momentum before collision will be equal to sum of momentum after collision. Now, we have two objects, tennis ball and a racket. Now, the mass of a tennis, we need the mass of a tennis times the initial velocity of a tennis plus mass of a racket times the initial velocity of the racket. Since it was not moving the racket, then that means there was no momentum for the racket. So times the initial velocity of the racket, even though we know that the initial velocity of the racket is 0, but we're gonna include on our formula is equal to mass of a tennis ball times initial velocity of the final velocity of the tennis ball plus mass of the racket times the final velocity of the racket, the one that we are looking for. Then let us substitute. The mass of the tennis is 0.1 times initial velocity of, and its initial velocity of 20 meters per second. The tennis was moving to the right with the initial velocity of 20 meters per second, and there was no momentum for the racket. Then that means plus 0 is equal to mass of the tennis is still 0.1 times the final velocity of the tennis. Now the tennis rebounds to the opposite direction of the motion. Then that means if we substitute here, we are not going to substitute positive 10 meters per second. We need to substitute negative 10 meters per second because it rebounds to the opposite direction of the motion. If it was going to the right, then that means it rebounds it's gonna rebound to the left. Plus the mass of the racket is 0.2 times the final velocity. Let me erase this part. Now on our right hand side of the equation, we're gonna get 0.1 times 20. 0.1 times 20 is equal to 0.1 times negative 10. Gonna get negative 1 plus the initial velocity of 0. Times the body of the tennis racket, which is 0.2 times the final velocity of the racket. We need to transpose 1 to the other side of the equation, so it's gonna be positive 1. 2 plus 1 is 3, is equal to 0.2 times the final velocity of the racket. Therefore, if you divide both sides by 0.2, 3 divided by 0.2, then the final velocity of the racket after it was after the collision with the tennis ball, it's gonna be 15 meters per second to the right, since it's positive. What just happened? Number 5, a 2 kg object moving at 4 meters per second to the right collides with a 3 kg object moving at 2 meters per second to the left. After the collision, the 2 kg object moves at 1 meters per second to the right. Calculate the velocity of the 3 kg object after the collision. Now, remember sum of momentum before collision. Sum of momentum before collision will be equal to sum of momentum after collision. So mass of object number 1 plus times its initial velocity plus mass of object number 2 times its initial velocity will be equal to mass of object number 1 times the final velocity of object number 1 plus mass of object number 2 times its final velocity. It's object number 2. Let me erase the top part. So the mass of object number 1, let me attach the pen first. So the mass of object number 1 is 2 kg. We are given in a statement times its initial velocity was moving to the right with 4 meters per second plus mass of object number 2 is 3 kg times its initial velocity of 2 meters per second to the left, which is going to be -2, is equal to mass of object number 1 is 2 and the final velocity of object number 1 is 1 meters per second to the right. So it's going to be +1 plus mass of object number 2 is 3 times the final velocity of object number 2. Let us do math now. 2 times 4 plus 3 into -2, we're gonna get 2. So on our right hand side, it's 2 times 1, it's 2 plus 3 times the final velocity of object number 2. If you transpose 2 to the other side of the equation, it's going to be 2 minus 2. We're going to get 0 is equal to 3 times the final velocity of object number 2. Let me erase the bottom part. Now we need to divide both sides by 3. If we divide both sides by 3, our final velocity will be 0 meters per second. Then that means this object was super stuck. It didn't move after the collision. Try this one. Feel free to take a shot and feel the pen. Try this one. A 5 kg object moving explodes into 2 possible pieces. One with a mass of 2 kg moving to the right at 6 meters per second, and the other with a mass of 3 kg moving to the right at 4 meters per second. Calculate the velocity of the 5 kg object before it explodes. Now, both of these objects are moving at the same direction. Then that means this question is pretty simple. So its sum of momentum before collision will be equal to sum of momentum after collision. So its mass of the 5 kg object times its initial velocity is equal to mass of a 2 kg object. Let me say mass of these two objects is gonna be, this is object number 1, object number 2, object number 3. Object number 1 is a 5 kg object before it explodes, then times final velocity of this object number 2, plus mass of object number 3 times its final velocity. Now the mass of object number 1 is 5 kg. We don't know its initial velocity. Its initial velocity will be equal to mass of object number 2. The mass of object number 2 is 2 kg times 6 meters per second to the right, plus mass of 3 kg block, which is 3 kg times the initial velocity, the final velocity of 4 meters per second to the right. Now let us work out the initial velocity of this block before it exploded. Now 2 times 6 is 12. It's gonna be, oh, let me attach my pen. It's gonna be 2 times 6. 2 times 6 is 12, plus 3 times 4. 3 times 4 is 12. 12 plus 12 is 24. Divided by 5. So our initial velocity will be 24 divided by 5. It's gonna be 4,8. 4,8 meters per second. Then that means this object was moving to the right. Try this one. Try number 7. Try number 7. The best way to learn physics is to take practical action. So try this one. Feel free to take a shot and fill a pen. Try number 7. Number 7. A 10 kg object moving at 3 meters per second to the right collides with a stationary 5 kg object. After the collision, the 10 kg object moves at 2 meters per second to the left. Calculate the final velocity of the 5 kg block after the collision. Now they are looking for the final velocity of these 5 kg objects after the collision. We are given that the 5 kg object before the collision was stationary. For those of you who don't understand, what does it mean if the object is stationary? When the object is stationary, then that means the object was not moving to the left or right. Then that means the initial velocity for the 5 kg block is 0. So let us try this one. Sum of momentum before collision will be equal to sum of momentum after collision. Now let us call this 10 kg as object number 1, this 5 kg object as object number 2. Now mass of object number 1 times the initial velocity of object number 1. What happened here? What just happened here? Let me erase here. No, sometimes things they just happen here without any reason. Plus initial velocity plus mass of object number 2 times initial velocity of object number 2 will be equal to mass of object number 1 times initial, now it's final velocity of object number 2 plus mass of object number 2 times final velocity of object number 2. Mass of object number 1 is 10 kg times the initial velocity for object number 1. The initial velocity for object number 1 is 3 meters per second to the right. Now object number 2, this 5 kg block was at rest, was stationary before it collides with this 10 kg block. Then that means this object was not moving. The initial velocity is 0. Now the mass of 10 kg, the mass, whether it's before or after collision, the mass of the objects does not change. So it's still 10 kg, but the velocity changed from 3 meters per second to 2 meters per second to the right. So it's going, I mean to the left, it's going to the left with 2 meters per second, plus the mass of object number 2, which is 5 kg, times its final velocity. Now we need to work out the final velocity of object number 2 of the 5 kg block. Let me erase the top part. Let me erase the top part. Let me also erase here. Now 10 times 3 it's 30. 10 times 3 it's 30, is equal to 10 times negative 2, it's negative 20 meters per second, 20 kg meters per second, because this is momentum, plus 5 times final velocity of the 5 kg block. Now transpose this to the other side of the equation, so it's gonna be 30 plus 20 is equal to 5 times final velocity of object number 2. 30 plus 20, it's 50, is equal to 5 times final velocity of object number 2. Now if you divide both sides by 5, 5 and 5 will cancel out, and the final velocity will be 50 divided by 5, it's 10. 50 divided by 5 is 10 meters per second. Therefore, the final velocity for the 5 kg block will be 10 meters per second to the right, because it's positive. Now let us move on to the other practice problems. Thanks for watching this video, and don't forget to subscribe, like, and hit that bell icon for more content like this. I'll see you in my next video. Have a nice day.